Hello there. In the previous videos, we discussed several examples on how to calculate probabilities of events. So recall, the probability of an event E is defined to be equal to the cardinality of the event space divided by the cardinality of the sample space for which E is associated. Also, the probability of the complement can be found directly by subtracting the probability of E from 1, which is the probability of the sample space. In this video, we're going to discuss another concept that is associated to events and likelihoods, known as the odds of an event, and then do an example to illustrate the idea. Alright, so let us begin by defining the first term that we will use. And this is going to be the odds in favor of the event E, which we will abbreviate by O of E. So O of E is going to be defined to be equal to the probability of the event occurring divided by the probability of the event not occurring. So one can find this is just the same thing as finding the size of E divided by the size of E not occurring, right? Which is also equivalent to finding the probability of E divided by 1 minus the probability of E occurring. So this is the odds in favor of the event E. There is an alternative of this, and this is called the odds against E. And we'll describe properties of this in a moment. So the odds against E is the odds in favor of its complement, which is of course equal to the probability of E complement divided by the probability of the complement, which is the original event, right? One can easily prove that this is the same thing as finding 1 divided by the odds of E, right? Because they are just reciprocals of one another, right? So let's do a basic example. So example 1. So suppose you roll a 10-sided die labeled traditionally 1 to 10. So what is the probability of rolling a prime number? So this is the probability of the event 2, 3, 5, 7. 11 is the next prime number, so these are the only things that we need to consider. All right? So there's only 4 events in this, so that's going to be 4, and the sample space has 10 elements, 10. So that means the probability is going to be equal to 2/5. So that's the probability of obtaining a prime number by rolling a 10-sided die. So that means the odds in favor of rolling a prime number is going to be equal to 2/5 divided by the probability of not rolling a prime number, which is 3/5, which we can see is just 2/3. Some people will write this in ratio form as 2 to 3. So the odds in favor of rolling a prime number is 2 to 3. Let's work through another example that is going to be a little bit more fun. Let's assume we roll 3 7-sided dice, and let's assume they are each labeled 1 to 7. Right? So what is the size of the sample space? So by the fundamental counting principle, we know this is going to be equal to 7 cubed, which is the same as 343. Now let us consider a particular event. Let's consider the event E to be equal to the set having a sum at most 5. Alright, so a sum of at most 5. So what is the smallest sum that we can get? So we're rolling 3 7-sided die, and the smallest number on each of them is 1. So the first event is going to be 1, 1, 1. So this corresponds to a sum of 3, and that's the only way to obtain 3. So the next number to consider, of course, is going to be 4. So we can get 4 in a variety of ways. We can have 1, 1, 2. We can have 1, 2, 1. We can also have 2, 1, 1. One should be able to verify that these are the only possible choices. Now, what about getting a sum of 5? And this will be the last event because we want at most 5, right? So one way to get 5, we can have 1, 1, 3, 1, 3, 1, 3, 1, 1. So that's one way. We can have 2, 2, 1. We can have 2, 1, 2. And we can also have 1, 2, 2. Right? Are there any others? Well, if we look at the case where one of them is 4, the minimum value that the other two can have is 1. So we have 1, 1, and 4, which gives us a sum of 6, which is larger than what we want to know, right? So we have 1, 3, and 6. So 6 plus 3 plus 1 is going to be 10. So that means the size of our event space is going to be 10. I leave it to you to, as an exercise, to sort of get a pattern. What if I change this number 5 to be a little bit more larger, like 15? How would the problem change? Alright, so if this is the case, that means the probability of this event is going to be equal to 10 divided by the sample space, 343, which means the probability of not rolling a sum of at most 5, which is the same as the probability of having a sum that is more than 5, is going to be equal to 333 divided by 343. So we're just 10 less. So that means what? So that means the odds in favor of having a sum of at most 5 is going to be equal to 10 divided by 333. Right? And the odds against that is going to be 333 divided by 10. So the odds are more in your favor for the complement of E, not E. So if you were to bet in a casino, you would probably want to wager for E complement and not E. So a couple patterns or properties that you should be able to notice. So what if the odds in favor of E is approximately equal to 1? So that means E and E complement pretty much have the same exact size. So it's equally likely, or approximately equally likely, to have either E or E prime occur. That means there's not really a significant benefit of choosing E or E complement. Now what if the odds of E is close to 0? So that means we're pretty much focusing on this case. So if the odds of E is close to 0, that means we pretty much have this as approximately not likely that E will occur. And if the odds of an event is arbitrarily large, which I'll denote as approximately equal to infinite. Of course, this is very far from infinite, but I hope you get my point. More so, I guess a more appropriate notation would be that this is significantly greater than 1. I guess is more valid. So if this is the case, then that means we're looking at O, E complement, right? So that means this is highly likely that E will occur. So this is just an introduction to the odds in favor and the odds against of a particular event, which sometimes are viewed in terms of ratios or fractions. It doesn't really matter. We'll come back to odds later on in the series when we talk about the logistic model and so on. Anyway, hope you enjoyed.